Okay, so this question's a little bit different. They told me the quadratic equation. They're telling me it's the number of automobiles can be predicted. So let's see, years after 1980. So in 1980 would be time zero. 1981 would be time one. So it's substitute in one, right? If we substitute in zero, that would be zero, that'd be a zero, that would be 384. So there's 384s that were purchased in 1980. A year one, in 1981, you'd substitute in one, so on and so forth. But that's not what this is asking us to do. They're going to ask us to solve this, to find a year when it's equal to a certain value. So they're telling us here, when is it equal to 1084? Well, that's the A. 1084 equals 2x squared plus 20x, plus 20x plus 334. So I'm going to set this equal to 0 because when we solve, so that's actually my open math. This would be, they might be looking at it like this. The other form they might want is to have you subtract 1084 from both sides. I would try the first one. If it doesn't like it, do the subtraction. Because we want to set these equal to 0, right? When we solve these by factoring, they always want to be equal to 0. So, and then let's see, it's going to be negative, and what is 1084 minus 334? So I'm seeing 750, and yes, I used a calculator. So now, I guess we're ready to start factoring this. So here's the equation that we need to try to factor. And the first thing I notice with this equation is that these are all even numbers. So I can divide these all by 2 and factor out that greatest common factor, that GCF. So divide everything by 2. 2x squared divided by 2 is x squared. 20x divided by 2 is 10x. 750 divided by 2 is negative 375 equals 0. And then that 2 is kind of problematic because it's in the way. Because it's a constant, can I divide both sides by 2 and get it out of the way? And what's 0 divided by 2? Oh, it's 0, right? So what's nice about this, setting them equal to 0, is you can divide by a constant. It doesn't change the answer. It just makes it a simpler question. Why doesn't it change the answer? Well, in Algebra 2, Mrs. Bruckner will show you this. So let's see, what's A? A is 1, B is 10, negative 375. I say that, she'll show you this, because right now you've got your hands full learning this stuff online, and it just, let's not worry about that. But here's what we've got. A is 1, so A times C is negative 375. So now that's kind of intimidating, that big a number. We want to know what are the factors of negative 375 that will add to give me 10. So two things I'm noticing. I know I have to have a positive number and a negative number because there's no way, the only way I get to multiply two numbers to get a negative is if there's one of each. And also because when I subtract them, I get positive 10 left. The bigger number is going to be the positive one. But what numbers do I use? Well, let's try doing a little factor tree and making this a little easier. So 375, I can divide that by 5. And what's 375 divided by 5? I could probably do that in my head, but I don't know. 375 divided by 5, I get 75. Well, I can divide that by 5 and get what, 15, and that I can divide by 5 and get 3 and 5, right? So what are the factors? Which ones can I multiply? And then when I subtract, I get 10. Well, I see right here, I see it. I know that 25 and then 15 and 25 minus 15 will be 10. So I'm going to go with positive. Let's see. Remember how I said I want the bigger number to be to be the ones I use. So before I erase my factor tree, I'm going to write 25 and negative 15. And you see how I got those two by this 5 and this 5, and that 5 and that 3. So let me stop this and get rid of that. Okay, so now let's do the factoring. Let's do the setup. Well, A is 1x squared. C is negative 375. Then we're going to have a 25x and a negative 15x. And then what can I factor out? Well, this one I can factor an x out. On this one I can factor out 25, can't I? Isn't 375, doesn't that divide by 25? I believe it does. Oh, it does. So 25 I can factor out. Whoops, get the pen going here. And that's a positive 25. And then I can factor out, I can factor out a negative 15, I believe. And there's an x. Let me make sure the 375, oh yes. So that's the other factor. So what is it in factored form? X minus 15 and x plus 25. So those are equal to 0 still, right? So when does x minus 15 equal 0? And when does x plus 25 equal 0? So I'm going to add 15. I'm going to subtract 25. So I'm going to write it sideways here. X equals negative 25. Well, if times 0 is 1980, negative 25 doesn't make sense. So that's called an extraneous root. Good thing to learn about now. Extraneous roots are I erased that too much. I don't want you to erase things out that bad. We'll call it extraneous because it's a solution to an equation, but it doesn't work in the original question, so we're going to ignore it. So x equals 15. Let's go see how we can answer this MyOpenMath question with that. First year. So what they're looking for is the first year. So I don't think we want to write x equals, let me go to x. Black. X equals 15. I don't think we want to write in 15. I think what we want to do is take our 1980 and add 15, which was 1995. And that's what they're looking for there. Okay, and then before I leave this equation, I was back on MyOpenMath with this question, and they are looking, the answer that they're looking for is have this equal to 0. Remember how we said we could have it equal to the 1084? I think to get it right, exactly right, you'd want it set equal to 0. But I still bet it would take both. Okay, so hopefully that helps you do this complicated question.